Welcome to the office. We want to continue taking a look at trigonometric substitution. So now that we know what to do when we encounter various radicals, we want to go ahead and use that. So here we have a situation where it's the square root of a squared minus u squared. And we want to observe that within this. So it's written as 4 squared minus x squared to a power where that power is 3/2, right? So this 2, 1/2, factor of 1/2 gives us that square root. So just to help make things clear, I want to first recognize that this is equal to the integral of, the integral of 1 over the square root of 16 minus x squared being cubed. So that's the first thing that I want to recognize. Then, based on what we had discussed on our intro video, we want to make the substitution, let this thing be equal to, right, a here, right, this is 4 squared, so we want it to be 4 times the sine of theta, based on our previous example. So then we differentiate to find dx is equal to 4 times the cosine of theta d theta. So we go ahead and make that substitution, and then this is equal to the integral of, right, we know exactly what this is going to give us. We know that a squared minus a squared times sine theta is going to give us exactly that a squared cosine theta. So this is 1 over, if we recognize this again as, make our substitution, 4 squared minus 4 squared sine squared theta times 4 cosine, that's going to be cubed, 4 cosine theta d theta. Then we can recognize that this is the integral of 1 over the square root of 4 squared times cosine squared theta being cubed times 4 cosine theta d theta. And this is equal to the integral of, right, we can take the square root at this point. So this is 1 over, not 2, but 4 cosine theta, but this is being cubed. So it's 4 cosine cubed theta times 4, and the 4 needs to be cubed as well, 4 cosine theta d theta. So once we're here, we have some cancellations. Cosine theta cancels out with one of the cosine thetas. 4 cancels out with one of the 4s. So we're just, right, we have a little bit of reduction there. So if we copy that down onto the next page to continue our calculations, this is the integral of 1 over 4 squared is 16. So I can actually pull that out as a constant multiple. And this is 1 over cosine squared theta d theta. Once I'm here, I recognize that this is secant squared, so 1/16 times the integral of secant squared theta d theta, and I recall that the integral of secant squared is tangent. So this is 1/16 times tangent theta plus c. And then we say to ourselves, but that's fantastic, but I need it in terms of x, so what is this in terms of x? So this is why we go back and we draw ourselves our fancy triangle with appropriate labels. So if we use that x is equal to 4 sine theta, this is the same thing as saying that, let's see here, put this in black a moment. All right, this gives us that, maybe write it down here. If x is equal to 4 sine theta, then x over 4 is equal to sine of theta. So if this is our angle, and we know that sine is opposite over hypotenuse, then the opposite side must be x, and the hypotenuse must be 4. Using our knowledge of how to find side lengths of a right triangle, that would mean that this side is the square root of 4 squared minus x squared. So that's fantastic. That allows us to evaluate tangent as opposite over adjacent, giving us the value of 1/16 opposite over adjacent plus c. And that is our integral. So that example was relatively quick and straightforward, I think. So that should work out pretty nicely for us. And we'll take a look at some more examples. We'll take a look at 2 more examples. And then one example will be posted, but it won't be part of what I'll consider our lecture notes. It'll be kind of a supplemental example. So I'll see you guys back in the office here shortly.